Today we'll do a few proofs, okay? And before doing those proofs, we have to know integers. What are integers? Na? You see 0, 1, minus 1, 2, minus 2, 3, minus 3, dot 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 dot, 4, minus 4, 5, minus 5, dot dot dot. These are called integers. Okay. Now we have to know rational numbers. Rational numbers. A number in the form P by Q, where P and Q are integers. P and Q are integers and Q not equal to 0 is called a rational number. Okay. You see 2 divided by 3, it is a rational number because 2 is an integer, 3 is an integer. 4 divided by 6, this is also a rational number. Na? 4 is an integer, 6 is an integer. In its lowest form is by cancelling 2. That is 4 by 6 is nothing but 2 by 3. Now this is the lowest form of this. So one more thing you see, when we take a rational number in its lowest form, then this numerator value and denominator value, these two value will have only one common factor, and that is 1. 1 is the only common factor. You see 2 and 3. 1 is the common factor of 2 and 3. So these 2 and 3 are called co-primes. Two numbers are said to be co-primes if they have only one common factor, which is 1. Okay. Similarly 6 and say 7. Now 1 is the only common factor of 6 and 7, and therefore 6 and 7 are called co-primes. Okay. So rational number, you have already understood what a rational number means. 2 is also a rational number because 2 can be written in the form 2 by 1. So 2 is an integer, 1 is an integer. So P by Q form, so 2 is an integer. Okay. Now irrational number, suppose 8. If I take square, 8 is non-square number. It is not a square number because 1 square 1, 2 square 2, 3 square 9. We are not getting 8. So 8 is not equal to 8 is not a square number. Understood? So and a square root of a non-square number is called irrational number. And a square root, this is square root, square root of a non-square number is irrational. Okay. Now we'll prove that root 2 is irrational. To prove this, we will use contradiction method. Contradiction method. Okay. Now solution. Let root 2 be rational. We have to prove it is irrational. We let root 2 be rational. Since root 2 is rational, so root 2 can be written in the form P by Q. P and Q are co-primes. Just I have shown you 2 by 3, lowest form of a rational number. So 2 and 3 are co-primes. So P and Q are co-primes. And Q not equal to 0. P and Q co-prime means 1 is the only common factor of P and Q. We have assumed it here. Now use square on both sides. Two p squared by q squared. So 2q squared is equal to p squared. That means p square is divisible by 2 because p square is equal to 2q square and 2q square is divisible by 2. Therefore, p squared is divisible by 2. P square is divisible by 2 means p is also divisible by 2. Why? Suppose p square value is 16. Then p is equal to what? 4. 4 is divisible by 2. Okay. Suppose p square is equal to divisible by 2 na. P square is you are writing suppose 8. P square is 8 you are writing. Okay. So 8 is divisible by 2. Now p will be what? Root over 8. Root over 8 means 2 root 2. Na? So 2 root 2 is not integer. Na? 0, 1, minus 1, 2, minus 2, 3, minus 2. These are integers. Na? So p and q are co-prime. So p and q are co-prime means p and q must be rational integers. So if I take p square is equal to 8, then p is equal to 2 root 2 which is not integer. So p square is equal to 8 is not possible. Na? So it may be 16. Na? It may be 64. Then it is 8. Na? Integer. Na? It may be suppose 64 100 na 100 divisible by 2, then it is what? 10 na 10 is divisible by 2. Okay, so if p square is divisible by 2, p must be divisible by 2. Okay, therefore p is divisible by 2 means p is even. So p is equal to, I can write in the form 2m. M is an integer. M is a 2m form. M value 1, then 2, M value 2, 4, M value minus 1, minus 2, minus 2, minus 4. Na? So ultimately, since p is also divisible by 2, so p can be written in the form 2m and m is an integer here. Now, p squared (4m squared) p squared is equal to how much? 2q squared. 2q squared. Okay, that means q squared is equal to what we are getting? By dividing 2 on both sides, we are getting 2m squared. 2m square means it is divisible by 2. That is q square is equal to 2m square means q square is divisible by 2. Therefore, q squared is divisible by 2. Q square is divisible by 2 means q is also divisible by 2. Also divisible by 2. That means what we have got? P and q both are divisible by 2. Na? But what we assume? P and q are co-primes. That is, p and q are only divisible by 1. Na? We assume. But now we see that p and q are also divisible by 2. Na? So our assumption is wrong. Na? Our assumption is wrong. PQ are co-primes. That is, this is a rational number. This is a wrong assumption. Na? That is, we get a contradiction. Here we see that p and q are co-primes, and now we see that p and q are not co-primes. So there is a contradiction, and this contradiction we have got because of assuming root 2 a rational number. So our assumption is wrong. So root 2 cannot be a rational number. It is irrational. No. We assumed that Pn we assume that P and Q are co-primes. Thus, it is a contradiction. It is a contradiction. Therefore, our assumption or our assumption, ASSUMP, assumption is wrong. That is, our assumption root 2 a rational number is wrong. So our assumption is wrong. Therefore, root 2 is irrational. Okay, hence proved. Understood na? Now we will prove. Prove that root 3 is irrational. Root 3 is irrational. Okay. Here also we will use contradiction method. Solution. Let root 3 be rational. Therefore, root 3 can be written in the form P by Q. P and Q are co-primes. P and Q are co-primes. And Q naught is equal to 0. Now we square on both sides. That is 3 squared is equal to P square by Q square. Okay. Nine Q square is equal to P squared. Na? Oh, sorry. Root 3 square is 3. So P square is equal to 3Q square. Therefore, P square is divisible by 3. P square is divisible by 3 means P is also divisible by 3. Okay. So P square is equal to suppose 9. Then P is equal to what? 3. So 9 is divisible by 3. That means this P is also divisible by 3. Suppose P square is equal to, you are writing suppose 27. So 27 is divisible by 3. So P is equal to root over 27. Root over 27 means 3 root 3. Na? 3 root 3. Now you see that P co-prime, P and Q are co-prime means P and Q are integers. So P must be an integer. So if I take P square is equal to 27, P is not an integer. Na? So P square cannot be 27. It can be 9, it can be 81. If I write 81, then P is equal to 9. Okay, and 9 is also divisible by 3. Okay, so if P square is divisible by 3, then P is also divisible by 3. Na? So therefore what we can write? P is divisible by 3 means P can be written in the form 3m. M is an integer. M is an integer. Na? If I take m equal to 1, then 3 equal to 3, 3 divisible by 3. If I take m2, then 6 is also divisible by 3. If I take m3, then 3, 9 is also divisible by 3. So P can be written in the form 3m since P is also divisible by 3. Now we square on both sides. P squared 9m squared. P squared is equal to what? 3Q squared. That means what we can write? By dividing both sides by 3. Na? What do we get? Q squared equal to 3m squared. Na? That means what we are getting? That means we are getting 3 square, Q square is divisible by 3. Q square is equal to this and this is divisible by 3. That means Q square is divisible by 3. Therefore, Q square is divisible divisible by 3. That means q is also divisible by 3. Q is also divisible by 3. That's what we get. Both, therefore both P and Q are divisible by 3. Okay, but what we assume, P and Q are co-primes, that is 1 is the only common factor of P and Q, that is P and Q are only divisible by 1. But what we have said, P and Q are divisible by 3, that is 1 also, 3 also, that means. Na? But our assumption, in our assumption, we assume that P and Q are co-primes, that is they are divisible by 1 only. And now we are watching that P and Q are divisible by 3. Na? Therefore, our assumption is wrong, that PQ are co-primes, this assumption is wrong. Na? Contradiction, there is a contradiction, you see, PQ are co-primes, but now we see that PQ are not co-primes. Na? Co-primes, not co-primes, so they are contradiction. Na? And this contradiction we get because of assuming root 3 a rational number. Na? So it cannot be a rational number, that is. Na? Our assumption is wrong, so it is irrational. But we assumed that P and Q are co-primes, that is only 1 is the common factor, na? That is they are only divisible by 1. But we assume that P and Q are co-primes. Therefore, this is a contradiction. This is a contradiction. PQ are co-primes, and here we see that PQ are not co-primes. Therefore it is a contradiction. Therefore our assumption is wrong. Our assumption is wrong. That is our assumption that root 3 a rational number is wrong. Na? So our assumption is wrong. Therefore root 3 is not a rational number, it is irrational. Therefore root 3 is irrational. Hence proved. Okay. Now you see, now another question, prove that 2 plus root 3 is irrational. Here also you will use contradiction method. Solution. Let 2 plus root 3 be rational. Therefore 2 plus root 3 can be written in the form P by Q. P and Q are co-primes, or P and Q are integers, same thing, na? P and Q are co-primes, or also you can write integers, na? When we write this in the lowest form, that co-primes, na? Co-primes, if P and Q are co-primes, means P and Q are integers. Therefore root 3 is equal to P by Q minus 2. This means root 3 is equal to P minus 2Q. So you see P and Q are co-primes, that is P, Q are integer. Then P minus 2Q is also integer, and Q is also integer. So this one integer, this was integer, means this is P by Q form. So this is a rational number, and this is equal to root 3. Root 3 is an irrational number. Na? So rational is equal to irrational. This is contradiction or not? So this is equal to this. When we see that this is equal to this is irrational. And when we don't see this one, then we will think that this is a rational number, because P, K and Q are integers. Then P minus 2Q integer, Q is integer, that is P by Q form. So this is rational number. But when we see this, that this value root 3, that is this is irrational number. Na? So sometimes we say this is rational, and sometimes we say this is irrational. So this is a contradiction, and we get this contradiction because of assuming this 2 plus root 3 a rational number. So our assumption is wrong. So this cannot be a rational number, it is an irrational number. P minus 2q minus q is rational, but root 3 is irrational. Therefore, this is a contradiction. This is a contradiction. Na? Therefore, our assumption is wrong. Therefore, 2 plus root 3 cannot be a rational number, it is irrational. Hence proved. Okay. Now, this is Prastuti. Okay. This was published in 2025. Okay. And this book is a very standard book. It contains new types of questions which Sheba board will follow. Okay. And this book has been written by Shiksha Kendra Samiti Assam. Na? Shiksha Kendra Samiti Assam, and I am also a member of this committee. Okay. So I am also involved in writing this book. Na? So a few questions from this book today I will show. And this is also another book. Okay, Bunyad Ganit. This has also been written by Shiksha Kendra Samiti. I am also a member of this committee, and the descriptive part of this book, the entire descriptive part of this book has been written by me. Okay, this is in Assamese medium, and its English version is going to be launched in the market very soon. Okay, this will contain question as per latest circular and sample of question papers. Okay, various types of questions are available here. Okay, so I will also show the solution of problems from this book. Okay. Prove that 7 plus 3 root 3 is an irrational number. Given that root 2 is irrational, we know it root 2 is irrational. Now we have proved. Na? So I have to prove that 7 plus 3 root 2 is irrational. 7 plus 3 root 2 is irrational. So contradiction method we will use here. Solution, let 7 plus 3 root 2 be rational. Therefore, I can write 7 plus 3 root 2 is equal to P by Q. This can be written in the form P by Q. P and Q are co-primes. Co-primes means integers, but having common factor 1 only. That is, 1 is the common factor of P and Q, are co-primes. And Q not equal to 0. You can write P and Q are integers also. Okay, no problem. You see, P and Q are co-primes, means P and Q are integers. So P integer minus 7Q integer, so P minus 7Q integer, and Q is integer. That is, this is in the form P by Q. This is in the form what? P by Q form. Na? Form is P by Q. Na? So form is P by Q. This is integer. This is integer. Integer by integer. That is P by Q form. That is, it is a rational number. P minus 7Q by Q is rational. Sorry, this 3 you take to this side. Okay, and 3Q is also rational number. So sorry, integer. 3Q is also integer. Q integer means 3Q integer. So integer by integer, rational number. So this is rational. And you see root 2 is irrational. This is rational, this is irrational. Rational is equal to irrational. How it will be possible? Rational is equal to irrational. It is impossible. Na? So this is a contradiction. It is irrational, it is rational, it is irrational. So this is a contradiction. Na? So this is a, therefore, this is a contradiction. That means when we don't see root 2, na, then we see that p minus 7q by q is rational. But when we see root 2, that is this is equal to root 2, then this value is root 2 means this is irrational. So sometimes it is rational, sometimes irrational. This is not possible, na? So this is a contradiction. We see this is rational. Again we see no, this is not rational, this is irrational. This is a contradiction. So we have got this contradiction for assuming this to be a rational number. So this is not a rational number. Na? This is irrational. This is a contradiction. So our assumption, we have assumed this one to be a rational number. So as our assumption, therefore our assumption is wrong. Our assumption is wrong. Therefore 7 plus 3 root 2 is irrational. Understood? 7 plus 3 root 2 is irrational. Okay? Now one more problem you see. We will do it using Euclid's division algorithm. In the last class I discussed Euclid's division algorithm, and problem of this kind I showed. A trader needs to pack 2 to 5 kg of P and 1 to 5 kg of gram sheet in bag such that each bag weighs the same. That is, each bag, the weight of each bag should be same. Each bag should contain either P or gram. If this, that means in one bag only one item is present. Find the greatest amount of P or gram that the trader can pick. That is, each bag should be of equal weight. And moreover, what mentioned? Maximum greatest amount of P or gram that can be packed or kept in one bag. We want maximum. Okay. So in the last class, in solving the Borfi problems, maximum number of Borfis in one stack, and each stack should contain equal number of Borfis. In solving that problem, what we did? We found out the highest common factor. Highest common factor, and that highest common factor is the maximum number of Borfis in each stack. So here also highest common factor is the maximum amount of each item in the bag. Okay, and each bag also contains equal amount of the item. Okay, so we have to find out the HCF. We have to find out what? HCF. 225 kg of P, 125 kg of gram. So 125 is smaller, it is greater, so it should be divided by this 1. So 125, so it is 100. So this 125 should be divided by 100, then 100. This is 25, 100, 400. So this is the divisor for which remainder is 0. So this divisor is the highest common factor, and this highest common factor is the greatest amount of P or gram that trader can pack in each bag. greatest amount of P or gram that the trader can pay. The trader can pick in each bag is equal to 25 kg. Okay, I will show more and more convoluted problems gradually. So this is my WhatsApp number. Again I am giving you. If you have any problem in understanding this, you can send a message, okay, there. Okay, thank you very much.